Hello everybody again, and welcome to the Roundtable, episode 6. We have a globe earther who is going to do a presentation this evening, and I've actually watched this presentation and he has put an awful lot of work in it, that's all I can say. I believe the video itself is around about 28 minutes long, so you better pin your ears back and have a listen to what he's got to say. If you're there, BM Furball, do you want to say hello?
Hey Ranty, thank you for having me.
No problem, nice to have you. And yeah, like I said before, I congratulate you for the amount of effort and work that you actually put into the video. So I do appreciate you bringing it to the table for everyone to see.
Thank you.
No worries. Right. So without further ado, we might as well get this show on the road, and let's see. If you want to pop yourself back on mute, we'll see your video, and I hope everyone enjoys it.
Hey everyone, I want to take a quick minute just to tell you about something that's going on this weekend. Recently, Ranty Flat Earth decided that he's going to open up his platform to globe earthers to present information that they feel validates their beliefs, and then initiate a discussion afterwards so that we can actually have a conversation. This is a very noble gesture for Ranty, and I applaud him for it, but I'll let him describe what the intent of this endeavor is.
Okay, so going forward, a lot of my subscribers are going to be asking what my next line of research was going to be, and because I've spent so long doing optics, I really didn't want to spend too much time finding out all the ins and outs about other people's beliefs and why they believe in certain things and what their proofs are. So being a part of the Flat Earth debate team has been great. You know, more recently though, we haven't had a thorough discussion with the Globers. So I thought, well, how about I open up the platform in a way that allows them to come in, and I mean this from the side of the Globers, and to concavers and to flat earthers, so it's literally open to anybody, to come onto my platform, do a live or pre-recorded actually presentation, anywhere from 10 minutes to 45 minutes in length, on a very niche specific topic involved with flat earth. So it could be like gyroscopes, or it could be about gravity, or whichever it would be, you know, and give their reasons in detail with a presentation exactly why they believe in that for their model. So a Glober can come on with their reasons why they believe gravity is real in regards to the model for the globe. And then the format's going to be that they come on, they do a presentation. I don't interrupt them a single bit. In fact, I won't ask them any questions in the entire thing. So they come on, they do the presentation. We then open up the conversation to the chat people, and we ask them, can you ask some questions? You know, so people will ask some questions. The guest will then decide whether or not they wish to answer it. If they don't feel they can answer that particular question, they can choose to ignore the question or just say, I don't know, I'll find out, or whatever. And then we'll end that particular segment. So that will be finished then. So that will be one show, done and dusted, where a Glober has come onto a Flat Earthers channel, told my audience and whoever decides to show up at the time why they believe in a certain thing.
So I immediately sent Ranty an email saying that I'm game. I sent him a list of the general topics that I'd covered in the past, and let him choose which topic he would like for me to present. Ranty selected the Southern Hemisphere. So what I'm going to present to you now is what I will be presenting to his audience on Friday night. Time of the event is 9 p.m. London time. So if you'd like to tune in and see how his audience reacts, I invite you. I'll be there watching as well, and answering questions that anybody could have. So the following is a combination of 3 videos I've done in the past, all that support that the Southern Hemisphere demonstrably proves the Earth is not flat. Today we're going to take a look at time, the sun, and navigation. First, let's look at the history of time. In today's modern age, everyone has become accustomed to the base 10 metric system. But have you ever wondered why there are 24 hours in a day, and 60 minutes in an hour, and 60 seconds in a minute? Egypt is generally credited with being the first culture to divide the day into smaller parts around 1500 BCE. However, when they did this, they used a base 12 system. The exact reason for the ancient Egyptians' value of the base 12 system isn't known, but there are several theories. Some believe it was based on the 12 lunar cycles in a year, while others actually believe that it's based on the 12 joints in your fingers on one hand, when you exclude the thumb. And with the joint method, you can actually count to 24 by using both hands. Early Egyptian sundials divided the day into 12 equal parts of sunlight, but these parts would vary in length based upon the time of year and the amount of sun you were receiving. Nighttime was similarly divided into 12 hours through various celestial objects, and once the concept of a 24-hour day was in place with the Egyptians, it just kind of stuck. The idea of fixed hour lengths didn't begin until the idea of heliocentrism began with the Greeks. Astronomers needed fixed time to document their observations at night. Around 140 BCE, Hipparchus proposed to fix the length of an hour into 24 equal parts, day and night, as measured on the equinox. While astronomers began to use this method during the time of the Greeks, laypersons continued to adjust their hours to the daylight hours until the 14th century and the advent of the modern clock. When dividing the hours into subparts, Hipparchus and the Greeks used the Babylonian system of base 60, which they had inherited from the Sumerians around 2000 BCE. This base 60 system was also used for measuring angles and continued in mapmaking and geographical coordinates. Around 200 BCE, Eratosthenes used this system to divide the globe into 360 degrees, allowing for proper identification of one's location on a map. These degrees are today's lines of longitude, and measuring them is the point of today's video. How are these lines of longitude used to find your location on land? Easy. The sun and time. At any given time on the globe, or even on an AE map, the sun is directly over some point on the ground. This is called local noon. And by knowing the track of the sun for your location, and being able to identify exactly when local noon is, you can identify your longitude. But how? Remember, the day was divided up into 24 equal parts. The sun travels 360 degrees around the globe, or across the plane, in that 24 hours. So this means that the sun will travel 15 degrees per hour relative to the crown. And this works on a globe and on the AE map. But to identify your point on the map, you need a fixed reference and an accurate knowledge of time. Today we utilize Greenwich, England as our fixed point. So that is what we will be using for this demonstration. And we'll even use it on the flat Earth map. To begin, we will start with noon at Greenwich, which is 0 degrees longitude. For every person standing on 0 degrees longitude, this is the time of day when the sun reaches its highest climb into the sky. Again, local noon. Using a very accurate clock, if we allow 1 hour to pass, the sun will travel across the sky and will now be at 15 degrees west. At 15 degrees west, it is now local noon, and at Greenwich, it is 1 p.m. If we let 5 hours pass, the sun will be directly above 75 degrees west. This line of latitude is now at local noon, and Greenwich would be at 5 p.m. Knowing this information, we can identify where we are at on the globe or a plane. Here are the two keys to being able to identify the longitude for yourself. 1. you need to be able to identify what time it is for you. This could be done through various methods such as observing the sun's track through the sky. Galileo even proposed using the orbits of Jupiter's moons as a universal clock. And number 2, you need to know exactly what time it is in Greenwich, England. If you were to measure your local time and determine it to be noon, and then look at your Greenwich clock and determine that at Greenwich it's 9 a.m., you would know that you are 45 degrees east of Greenwich because of the sun travel time. The exact location even continues with the clock analogy with minutes and seconds. The Statue of Liberty is located at 72 degrees, 2 hours, 44.33 seconds west of Greenwich, England. This principle is the same on a globe or on an AE map. But here's where we run into some problems, and they're pretty big ones. On a globe, these lines run between the North and South Pole. Near the pole, these lines get closer and closer until they actually intersect at the pole. At the equator, they are the farthest apart, before narrowing down again and converging at the opposite pole. But on the AE map, the most widely accepted view of the flat Earth, these lines of longitude don't reconverge at the South Pole. They just continue to go on forever as they pass the equator and get wider and wider. And here's what the math says about the AE map. Viewing the AE map in 15-degree segments, because this is the 1-hour travel time of the sun, the distances between 0 longitude and 15 west are, at 70 degrees north, 577 kilometers. 50 degrees north, 1,155 kilometers. 30 degrees north, 1,733 kilometers. And at the equator, 0, 2,599 kilometers. These measurements were based off of a 15-degree triangle and are indisputable. Measuring the distances from the North Pole to each of these lines of latitude are what gave me these distances between 0 and 15, the open end of the triangle. Now, these measurements alone cause a problem, because using spherical geometry, the same distance at the equator is actually 1,642 kilometers. We've gained almost 1,000 kilometers of land between 0 and 15 at the equator, distance that by all accounts for humans that actually live on the equator doesn't exist. Our problem gets even worse as we go past the equator. The AE map forces this 15 degrees to continue to grow almost exponentially. This is what these distances look like.
At 30 degrees, we have a 2,000 kilometer gain. At 50 degrees, we have a 3,000 kilometer gain. And at 70 degrees, we have over 4,000 kilometer gain.
Much of this land is out to sea or in the fictitious land of Antarctica. How does this actually look in reality? Let's take a look at Australia, the upside-down country that others will still claim doesn't exist. And for this project, we're going to take a look at Sydney and Adelaide. On a globe, the direct line distance between Sydney and Adelaide is about 1,157 kilometers. This is at the 34-degree longitude line. This places the straight line distance between Sydney and Adelaide on the AE map at over 3,000 kilometers. A gain of more than 1,900 kilometers. A gain that no person has ever documented on the ground. And this isn't a no man's land. It's not like it's out to sea that has no roads. There are modern paved highways between Sydney and Adelaide. And to date, no Australians have complained that they ran out of gas driving between these two locations because the road was actually longer than the maps claimed them to be. But what about flights? Let's take a look to see if there's any flights between Sydney and Adelaide. And wouldn't you know it, there are. At least once every day or two. And these are real flights with real people that get on a plane at one city and get off a plane at the other city. And the travel time between these two cities is about an hour and a half. For this flight to fit into the flat Earth world, that plane would need to be traveling at an average speed of 1,924 kilometers per hour. That's not max speed, that's average speed
takeoff to touchdown. Max speed would be about 200 kilometers an hour faster. Now, flat earth gods like Jaren will claim that we don't really know how fast planes can fly, but until he can show me a commercial jet that has a max speed of over 2,000 kilometers an hour, a speed approaching Mach 2, he doesn't have a leg to stand on. Our old friend Jaren has found an article that he believes proves his feelings of the Southern Hemisphere and how planes can actually get from Australia to South America. So let's see what Jaren has to say.
What's going on, everyone? It's Jaren from Jarenism, back with a short video for you. A video where I will be showing you a recent article that allows me to feel, in a way, kind of vindicated. A while ago, when talking about planes traveling in the Southern Hemisphere, I stated that those passenger planes could be traveling faster than the speed of sound and actually be traveling much greater distances without anyone knowing. The jet stream is moving so fast right now that commercial planes are traveling faster than the speed of sound. If you're flying east today, you're in a whole lot of luck. The jet stream, that funny little channel of high-altitude air that flows over the United States and northern Atlantic, is moving at unheard-of speeds, delivering commercial jets to their destinations nearly an hour ahead of schedule, the Washington Post reports. In fact, one Virgin Atlantic flight traveling from Los Angeles to London notched a speed of 801 miles per hour over Pennsylvania, which, had it been on the ground, would have been faster than the speed of sound.
Well, maybe he's got something here, because if planes can actually travel that fast, maybe they could traverse the distances of the Southern Hemisphere required on a flat Earth.
All right, here you see I've brought up Flight Radar 24, which is a site where you can track flights, and I've just typed in Sydney to Santiago. And if we zoom in here, you can see what happens. And the problem that we have with these flights is that as soon as they take off from Sydney, it gets out over the open water and, of course, drops off and just skips to that next location. And then it will fly over New Zealand there. And again, once it gets to a certain spot, it just disappears from radar until it appears all the way on the other side over here by Santiago, Chile. So again, you can see that this plane got up to almost 680, I think I saw 684 miles per hour ground speed, and then it disappears. So we have no idea how fast this plane could be possibly traveling once it gets up high enough to be in those jet streams and traveling across the Southern Ocean. And then you don't see it till it hits the other side. So we have no idea what's happening in this downtime where the satellites can't pick up, I guess, the speeds of this plane. And so this is just a little quick example that I made here. Let's say we've got a plane going Sydney to Santiago, as we just showed. That travels 7,000 miles in 12 hours, which is about the average flight time. 7,000 divided by 12 equals 583 miles per hour. All right, but what about the jet stream? So remember, it's helping the plane with close to 250 mile per hour winds. So if the plane is being helped, well, 583 miles per hour minus 250, is the plane actually going 333 miles per hour? And then it's getting the extra 250 to end up at 583? Well, that doesn't sound very efficient, does it? So let's look at it this way. What if that plane was actually going 625 miles per hour, which we saw, ground speed. We also know that that's easily under the speed of sound. 625 miles per hour plus 250 miles per hour, which would be the most efficient thing, is 875 miles per hour ground speed. Okay, so a plane from Sydney to Santiago could be going 875 miles per hour for 12 hours. 875 times 12 is 10,500 miles instead of 7,000 miles. I mean, quite a difference, right?
So Jaren is questioning the distance and speed of the airplanes as located off of New Zealand and off of the coast of Chile. So let's take that information and see what does it tell us with basic geometry. So here's our location off of New Zealand, a little bit off of the coast, kind of like Jaren showed. This is about the point where it dropped off of the GPS. And then we've also got our location off of Chile. Now, to figure out this in geometry, we need the distance between the North Pole and that spot off the coast of New Zealand. And when we measure that, we find that it is 14,846 kilometers from the North Pole. So that is our measurement number 1. Now we have our location off of Chile, and you'll notice that it is a significant distance farther north on the map. We'll just say that rather than a globe. And the distance between that location and the North Pole is 8,798 kilometers. So we now have
our distance 2 for our triangle. Now, on a globe, the distance between these 2 points is 8,800 kilometers. Now, I know Jaren used miles, but I'm trying to stay international here, so we're going to have to do a little conversion. This unaccounted for time, when the satellites don't see this plane, is just over 8,000 kilometers. So the next question we have to ask is, how far apart are these locations? Because on the globe, like I said, that's just over 8,000 kilometers. But if you use flat Earth math, first we need to know how far apart they are in degrees. And based upon basic map making, these two locations are 102 degrees apart. Now when we create our triangle with sides of 14,846 by 8,798 with an inner angle of 102.7 degrees, the distance between these 2 points is not 8,080 kilometers. It's 18,396 kilometers. So how fast would a plane have to be traveling to traverse that distance in that time? Well, I'll be honest right now and let you know that when I did this math initially, I didn't think it was that big of a difference. Because when you traverse that distance in 12 hours, you only get a speed several hundred kilometers an hour faster than Jaren is claiming, which is still more than any jet plane has ever claimed to travel. But what I'd forgotten is that it's a 12-hour flight from airport to airport. But we're not measuring airport to airport. We're measuring unaccounted for space over the ocean. And that time was only 8.5 hours. So in that 8.5 hours, this plane had to traverse 18,396 kilometers. And when I use Jaren's math, 18,396 divided by 8.5, how fast does our plane have to be traveling? It's not the 1,289 kilometers an hour converted that Jaren claims. It's 2,164 kilometers per hour. Unless you can find a jet stream that has a speed of 700 kilometers more than you're thinking it does, your math doesn't add up.
And now you see why anyone who says Southern flights prove the globe are either too scared to consider the alternative or just haven't researched enough.
MarineTraffic.com is an amazing website similar to the air traffic websites. It shows you virtually every boat that is on the ocean. And just like a lot of those other websites, it is a pay website with specific free features. By paying for the service, you're allowed to look at virtually any boat and their current and exact location on the ocean. Well, I'm a poor soldier, so I'm not going to subscribe to a website just so I can track boats. But as part of their free service, you are allowed to select boats that you would like to follow. And with that, they will send you an email once a day with the location of that boat, up to 30 updates per month. Now, those updates also include entries into harbor, exits of harbor, docking, mooring, so you may get 5 to 10 notifications in one day as your boat enters a harbor. So as part of this project, several months ago, I wanted to find a boat that was traversing across the southern hemisphere. And I found this boat, the Olivia Maersk. It was in New Zealand, and it was getting ready to sail across the Pacific to the northwestern coast of South America. I subscribed to the website, I signed up for this boat as a tracking, and then I just kind of forgot about it. And I got emails every day. I just brushed it off, not really thinking about it. But afterwards, I realized that by doing this, I did have legitimate data of exactly where a boat was crossing the southern hemisphere, and that maybe with that data, I'd be able to do some virtual observations of how fast it was going and where it was traveling. So I was able to plot out these specific pings on Google Earth. Now, you'll notice there's a gap in a couple of spots in the beginning. I honestly don't know if those emails didn't come through, or if I accidentally deleted them because I did not have the forethought to retain them. But since then, trust me, I have retained every email I've gotten from this website. And on Google Earth, you can see that the general line from these two harbors is straight. It is a straight trek across the globe, the Great Circle Route. And on that Great Circle Route, according to every measurement ever made by any sailor, ever, and by Google Earth, and by every map utilized by governments and private citizens who sail boats across the ocean, the distance between these two harbors is just over 10,000 kilometers. And this trek was made over about 12 days. And utilizing the simple gerund math, distance divided by time, the Olivia Maersk was traveling at approximately 35 kilometers per hour, or 18.8 knots. But that's not why we're here today. We want to see what the Olivia Maersk did on the flat Earth map. Now, I could do the math like I did last week, airport to airport, or harbor to harbor. But in this case, I don't need to do the port to port, because I actually know the exact locations during the trek. Last week, I didn't know the exact locations of the airplanes, because they drop off of tracking after they get over the open ocean. But this week, I have the exact locations as the Olivia Maersk traveled across the southern hemisphere. And you can clearly see that it is not a straight line according to the AE map. Now all we need to do is some basic math. First thing we need to know is the distance between the North Pole and each of these ping locations. Now, utilizing the longitude locations for each of these points, we're able to identify what the inner angle is between these locations. So now we have the lengths of two sides of our triangle, we have the inner angle of our triangle, and with that and basic geometry, we can identify the distance between these ping marks. Now remember, on the globe, the distance port to port was 10,000 kilometers at 18.8 knots of speed. But on the AE map, we don't double our distance. We more than double it to just under 25,000 kilometers traveled by the Olivia Maersk in 12 days. And with that distance divided by time, we're not doing 18 knots. We're doing 43 knots, more than double the speed of the boat. So now I ask you to remember, back to the beginning of this presentation, that the sun does travel 15 degrees across the plane every hour, and that based on that location on the line of longitude is measurable simply based on the location of the sun at that time of day to determine the distance between the two locations. And using this simple formula and this basic information, if the AE map were true, the southern hemisphere is vastly larger than anybody has ever accounted for. And if it's that much larger, then not only are airplane flights impossible, Jaren has tracked them across the ocean, and I've checked his math, and I've tracked boats across the ocean, and unless I've missed something drastic, I don't think my numbers are wrong. But I invite you to check my math. Thank you for your time.
Okay, well, we have seen your presentation. Thank you very much. I'm going to go for a little break now. I'm going to put some music on, and yeah, that'll do for now. And when we come back, we'll take questions. Line up, because I'm sure there's going to be quite a lot of people wanting to ask you some interesting questions about this. So here we go.
We're up pretty high, our heads are almost in the clouds, and their feet are chained to the ground with their chains of misery. They've got a hold of me, they won't let go of me. Let go of me. They might have gravity on their side, but something's pulling us high. Got the potential to fly. So let them be what holds you back from this one incredible chance. They're lucky to have had a glance at you. Are you defy gravity? They can be cruel and mean and a huge pain. Our heads are in the clouds now. Don't let them make it rain. A smile can be the sign they're missing out on their rainy day. They might have gravity on their side, but something's pulling us high. Got the potential to fly. Don't let them be what holds you back from this one incredible chance. They're lucky to have had a glance at you. Are you defy gravity? You defy gravity. They say we aren't strong enough, we don't have what it takes. I say yeah, they're wrong enough, and we'll show them someday. They might have gravity on their side, but something's pulling us high. Got the potential to fly. Oh yeah, don't let them be what holds you back from this one incredible chance. They're lucky to have had a glance at you. Are you defy gravity? You defy gravity. You defy gravity. Yeah, yeah. At you, are you defy gravity?
Well, I hope you enjoyed that music. Shout out to my friend in the chat, Jerenism. Nice to see you there, my friend. BM, are you still there?
Yep, I'm here.
Good stuff, good stuff. Right, so it seems that your presentation has gone down with mixed reviews in the chat. You're getting quite a lot of questions already. Right, are we ready to take some questions? If anybody wants to fire some questions, now's the time, and I will put them to you, BM.
Yep, go ahead.
No worries. Can you actually see the chat as well?
Yes, I can. Yep.
Cool. Okay, so if you see anything that's directed to you, if you just want to answer that, and if I see anything as well, I might put that question to you as well. Question: how is it possible to translate a spherical geometric globe with arced longitude lines to a 2D Euclidean geometric flat map accurately?
Euclidean.
Euclidean.
I'll be honest, I am not a math expert. I'm not an expert on anything geometric, and this is something that perplexed me for a while as I was making the original video, because if you use just straight up triangles in geometry to measure from the North Pole to the equator, you don't come up with the number that we view on the Earth, the viewed globe map, or the globe. It's different if you use a straight up triangle or if you use a sliver of a sphere. And I spent probably a month trying to understand this and trying to research it, and I still don't fully understand it, but I've seen several videos, and I know probably everybody will hate it, but Bob the Science Guy did a video on 3D geometry. Basically, it's different math, so they're not the same. So if you use, like I did, and I even mentioned it in the video, is when you take that sliver of the AE map down to the equator, it doesn't give you what we on Earth view as between 0 and 15 longitude as the distance, because the maths just don't work together. They're two different types of maths.
Okay, so Jeronism in the chat, he wants some clarity about the data that you inputted. So he wants to know if you showed 14,846 to New Zealand and 8,798 to Santiago from the North Pole.
I'd have to double check, but I think that's about what it was. And that was the locations off the coast as a ballpark approximation of where the plane left the map from the flight tracker.
Okay, shout out to JQ for giving a super chat which says BM Furball's presentation was a BM with a furball in it. P.S. Please never play that terrible music again. Okay. Right, question from the Adam Meakin. Did BM use the law of cosines to calculate his AZ projection distances?
I used straight up geometry with triangles. Because if the Earth is flat, then you don't have to use any type of special math to measure distances or angles because it's flat.
Okay, so would that be a yes or would that be a no?
No, I did not.
Okay, cool. Nathan Oakley seems to think that your entire presentation was using fallacies. Would you agree with that?
I would disagree, and I'd also like to point out that he spent half of the video calling me a moron repeatedly.
Okay, so question, where did you get the R value, radius value, that is the very presupposition your argument is based on?
I did not, because nothing in my video was about determining R or using math that relied upon R. You could, if we're going to go off of the two different models, a globe model and a flat model, and you're comparing the two, the information I presented about how far you've traveled based upon the sun, that works on a sphere of any shape as long as the sun travel time is still the same. As long as the sun is still traveling 15 degrees across the sky per hour, it doesn't matter what the actual size of the sphere is.
Question from Jeronism.
That just changes the speed of it.
Question from Jeronism. How much further north is Santiago, Chile to New Zealand?
I think I even mentioned, well, based upon those numbers, what was it, 18,000 or 8,000 and 14,000? It's Santiago, Chile is significantly closer to the North Pole.
You'll notice I'm not interfering here. It's like I ask the questions, and literally it's whatever you say, you know, I'll try and repeat the questions verbatim as I get them, you know, and literally, you know, it's you against the chat basically. So, you know,
yeah,
so
I was just
try
trying
not
to
interfere.
without trying to understand what the kind of like the basis behind the question is. But yeah, it is significantly farther north.
Right, okay. So we have from the Adam Meakin, but the triangles are scalene. You can't use standard, can you read that? So hatch hotole trig to calculate, whatever that said. Adam, you have the vocabulary of a chemist. Right. Did you understand that question?
Did not understand the question.
Could you read it yourself from the chat?
Yeah, I'm looking at it right now.
So it's something that you've not come across then. It's something, to be fair, it's the same with me. I've never even seen that word before, so I wouldn't know how to say it. Jeranism says that Santiago, Chile is 13,705 kilometers to the North Pole. Your numbers are wrong.
I was going for the location, but I have to check.
Well, he's stating that your numbers are wrong.
Yeah.
And ask him again for what the two numbers are.
If I'm wrong, then I did the math wrong. I don't think that changes the results, but I would. Yeah, I'll run the math again. Yeah, I'm not above being told that I'm wrong.
Okay, I mean, like I say, I mean, I'm not going to measure it out for you. I'm not going to check myself.
Yeah, I'm not going to be able to do it right now, but I will double check on that.
Okay, but this is, essentially this is what Jaren's saying. He's putting it to you that the calculations are wrong, but you're also coming back there and saying, well, if the calculations are wrong, the result still applies. It would be the same sort of result. Is that right?
Yeah, it'd still be this. The issue is still the same, that the southern hemisphere is significantly larger on a flat map than it would be on a globe.
Okay. Well, Jaren's tripling down here and saying that your numbers aren't just wrong, but they are totally wrong. Okay, right. So, any more questions? Any more questions rather than statements? Trying to look through. Can you see anything?
I'm not seeing anything.
Come on, guys. You can get some questions out. Come on. I'm in trouble with the missus with you guys.
Evidence
for
of
doing
core.
This show. Go on.
So somebody asked for evidence of a core. It's not what the video's about.
Well, that's true, yeah. Okay, so the Adam Meekins puts, if you don't know how he calculated this, then I would suggest if he has used standard trigonometry, then all of his maths is wrong. You have to use the law of cosines to calculate.
That would be if you're calculating on a globe. The basis for my calculations weren't global. They were flat.
Question.
And Jared.
Does BM think the globe model reification he presented is not based on R? If so, he is, as already demonstrated, a you-know-what.
Yeah. Well, if we're going to talk about a globe and flat, you kind of have to make some assumptions on both. You can't come at them with absolutely no knowledge. So if I'm going to talk about a globe, yes, it's going to have a radius. And if I'm going to talk about flat, it's going to be flat. So it's not a reification fallacy to impart some basic knowledge upon those models as you evaluate them.
Okay, so Matthew Stevenson says, yourself, BM, said that boats were travelling the Great Circle. How can you not have an R if it's travelling the Great Circle?
Are we talking on the globe or on the flat Earth? Because the contention I was trying to present is that if it was on a flat map, then there is no arc.
It's your question. You answer it how you see fit. I mean, at the end of the day, like I say, the presentation is to you. The questions come to you. You decide to answer them how you interpret the question.
Yeah. Could you reread that one again? I'm trying to find it in here.
Okay, let me just find that again. So it says, BM said boats were travelling the Great Circle. How can you not have R?
Trying to think of that. So yes, they are traveling the Great Circle. That is my contention, but I wasn't evaluating their Great Circle route. I mean, I did basic math, distance times time, or distance and time to find speed, but what I was actually personally doing for the math was on the flat map, which would not have an R. It did have an arc to it because the boat was curving to the left, but that's not R.
Okay, right, so the Adam Meakin says, this is flat trigonometry. He, yourself with respect, is wholly incorrect to suggest you could apply the law of cosines to a spherical surface.
Okay.
I have to put it to, because, when Adam doesn't really speak up very much, but when he talks about things like this, he generally knows. It's not something that I would expect him to say if he didn't actually know it applied to this actual video that you put together.
And like I said, I am not a math major. I am not a math genius in any fashion. This was me trying to use a layman's view of how a flat southern hemisphere would be distorted and not conform with what we see in everyday life. So if I got the math wrong, again, I'm not above being told I'm wrong. I would love to learn how I was wrong so I could do it better. But by evaluating everyday examples, the southern hemisphere doesn't fit.
Okay, well, to back you up, Bazaar actually puts the Great Circle map can be plotted on a flat map. From Jeranism, Santiago is 33.5 degrees south, New Zealand is 40 degrees, and he showed Santiago was half the distance from the North Pole as compared to New Zealand, even at 6.5 degrees difference.
I'm gonna save that and I'm gonna look it up. Not right now, but I'll follow up. I'll do a follow-up video if I've got math wrong.
Okay. I shouldn't put a pear next to my head, apparently. Hey, but I've got a peanut. I've got a peanut M&M head. So peanut M&M next to a pear. It's all good. Right. Let's see if we've got any more questions coming in. I want some questions, people. I don't want people just saying that he's wrong, and I don't want people just saying that he's done this wrong or that wrong, etc. I'm sure that this can be worked out in the future. I don't think he came in with any intentions to do anything other than put his own presentation together, which he has done, and it was very well put together, I have to say. You took a lot of care with that, so thank you for that. But yeah, I would like questions, please. Questions, not just saying that he's wrong. So if we've got any more questions.
And yeah, just to kind of explain the thought process that I had here is a comparison of a globe and a flat map. Globe map is pretty easy. It's a globe. Flat map, you have to make some suppositions because nobody has claimed that they have the map. And the basic supposition is that the North Star is directly above the North Pole, so that puts the equator and everything else getting bigger and bigger and bigger. And with that type of a map, the southern hemisphere has to get exponentially larger. So I know Jeranism criticizing me here. I understand that, but based upon this information, even if my math is wrong, the southern hemisphere is exponentially larger than we see it on a daily basis. So the jet stream that added 250 miles an hour doesn't add enough to make something go that fast. And how does the plane get back if the jet stream is one way? I know the accusation there is going to be that maybe there's jet streams higher. Show me evidence of jet streams higher and you might be right. But my view of this was, again, from a layman's perspective, how the southern hemisphere does not conform with what we observe in reality if the AE map is somewhat accurate.
Okay, so Logan Cook asks to talk about declination on a globe and how it works.
Trying to think of how that would. So I mean, you could view of declination by determining sun altitude. I'm just trying to think of how that would fit into this general line of questioning, because you'd be able to find out what time or where you are at by measuring the location of the sun based upon your spot. And then, like the first part of the presentation, if you know what time it is in Greenwich, and I apologize for pronouncing the W in the video. If you know what time it is in Greenwich and you use the sun to determine what time it is for you, that tells you how far away you are from Greenwich. And that works on the northern hemisphere and on the southern hemisphere. So that at least says that the lines of longitude
are straight lines.
Okay, Nathan, you've already asked that question, so I'm not going to ask that one because you've asked it so many times. He has answered it. So, yeah, just a general statement here by Oxbro Spirit, which puts the southern hemisphere ... presupposing a globe again. So it seemed obviously there's
So by
contention.
using the word sphere, by using the word sphere, I'm not presupposing a globe. I'm using the most colloquially accepted term for locations south of the equator.
Okay, I'm just waiting for the plain truth. He apparently has asked a couple of questions and I've missed them somewhere. So I'm still looking for more questions, people. And I'm not actually seeing... Oh, hang on. Yeah, that's from Nathan again. We need some questions, people. You've seen the presentation, surely?
Yeah, nothing in my presentation assumed R other than the fact that if one of the models is a sphere, it has an R. But
Okay.
I'm not presupposing what that R is.
Okay, so from the plain truth. So his question to you is, what primary source you have that the alleged heliocentrism of the Greek culture was spread wider than a philosophical idea?
Basic internet research, and it was just to have a foundation so people understood the topics I was talking about.
Okay, so no primary source then?
No, because it wasn't the main purpose for the video. It was just so that people had a general understanding, because I wanted people to understand the history of time, the history of navigation, and how important it was to identifying your location on a map.
Slightly off topic, but you did actually touch on it in your video. Do you agree with the current heliocentric distance to the Sun?
I would generally agree with it. I couldn't quote it off the top of my head. But from everything I've seen, I would agree that it is not small and local.
So this is a question from Skyflybright, who asks, why the Sun moves 15 degrees any place on Earth in 1 hour and couldn't work on a flat map?
Well, it could work on a flat map. It absolutely could work on a flat map. The first thing is that, again, like I said in the video, the sun does move 15 degrees per hour. So that is either accounted for by the movement of the sun itself or the rotation of a sphere, one or the other. And that's the initial supposition. It's going to be either the sphere is spinning or the sun is moving. And with that, those lines of longitude, if you are directly underneath the sun, it is noon for you, and everybody north and south of you, it is also noon for them. So that line of longitude is a straight line. So it would work on a flat map. The problem is that as you get farther and farther south away from the North Pole, those lines of longitude get farther and farther and farther apart. Where on the globe map, they reconverge at the South Pole. On a flat map, they would not reconverge. That means that those lines of longitude just keep getting farther and farther apart. And distances we know today conform with lines that reconverge.
Okay, so I'm sure that you said this before, but did you presuppose the R value?
No, at no time. I just presupposed a sphere and flat.
Okay. Please prove your hearsay Greek heliocentrism.
It wasn't the purpose of the video. It was background information so people understood what I was going to talk about. I might have been wrong.
You know something? I have no problem with somebody saying they might be wrong. I mean, to be fair, this is what this platform's about, and it's the first thing that I actually came out with, and I said, look, if you don't know the answer, don't try and say that you know the answer if you don't, because you're just going to look stupid. If you don't know the answer, just say we don't know the answer. I have no problem saying that I don't know answers to stuff. It doesn't mean that I'm wrong in anything. It just means that I haven't had time to research it, or I can't remember it at that moment in time. So essentially, there's no. From my point of view, you saying that you don't know that question, that's great, because I would rather you say that than make something up.
Yeah, and a lot of this, I spent a couple weeks researching this video. Again, a lot of that was just to get background information so people understood what I was going to talk about. So I didn't spend 5 months trying to boil down the history of people's beliefs, because that wasn't the core of the video. And somewhere I've got a list of where I got most of these references online, and it's because I read it, sounded good, verified it somewhere else, used it in one sentence in the video, moved on to the actual topic I wanted to talk about, which was lines of longitude.
Okay, so there is a question here about the lines of longitude. Which latitudes on the flat Earth map have the correct distances?
It would generally be anything up to the equator.
Okay, and another question actually. Why did Captain Cook log over 60,000 miles circling Antarctica?
I don't know. I've never researched Captain Cook.
Okay, the other thing I would say is I would recommend that you look into that story.
Okay.
Okay, so this is slightly off topic, but could you ask him if he believes in the force of pull, because it is related to gravity, but don't use the word gravity, just stop at pull.
I believe in mass attracting mass.
Okie dokie. Right, come on guys. I want to wrap up in around about 5 or 10 minutes, so if you guys want to put a few more questions. Right, question at 2056. What's this Trevor Austin put? Crack, it doesn't tell you the times that they put it. So, Trevor, you're going to have to ask the question again. Oh, hang on. I've just got it there. Yeah, he asked that. I asked him that question. More questions, please. More questions. I feel that you're being very honest here, BM. That's why I actually like. I prefer someone that comes in and just, hey, I don't know. If I've got it wrong, it's fine. It's not a problem. That's good. I like that.
And with what Jared said about the distances being wrong, I am intrigued on that. I want to make sure that I got the distances right.
I'm still waiting to see some questions.
A lot more about R.
Explain the double rainbows.
I can't.
Did your evaluation?
I'm not an optics major.
Did your evaluation use any directly measured distances?
Meaning, like myself measuring the distances? No. So for the distance measurements that I got, I went to several different websites that allow you to put in grid coordinates, and it would give you the straight shot distance between between those distances, and that is what I used for pretty much all of my calculations. So between 0, 0, North Pole, and where the boat started out from the harbor, and then from each ping point, 0, 0 is for one of the locations, and then the ping point is for the other, and it gives you the distance between those. And using left and right sides of a triangle, you can figure out the distance between the two. Knowing the three sides, you can get the distance, the inner angle of it. So I didn't use Google Earth for the distances because it was going to be too inaccurate trying to get it to the exact spot. So I found several different websites that just let you plug in a GPS coordinate. and that'll tell you the distance between the two spots. That's how I got all of my distances.
Okie dokie. So there's a nice comment come from Chris Cruel, who's put, thank you for the awesome presentation. Don't listen to the idiots spouting fallacies. So he's giving you he's giving you a thumbs up there. There does seem to be a lot of people that are already saying that you pretty much debunked entirely by having everything wrong in your presentation. But, you know, I mean, I guess this will all come out in the wash. You know, if there's flat earthers out there that actually want to put a presentation together to refute this, or even do their own videos on their own channel that actually just tackle this particular thing, that would be great. You know, but at the end of the day, gentleman's come on and he's openly admitted, you know, if he's got things wrong, he'll hold his hands up. You know, it doesn't have to be vitriolic, you know.
And all of the information that I've got, anybody should be able to replicate, especially for like the boat trip. Every email I got, it pops up on screen, and you can see the exact grid coordinate for that boat at that time. If I got the start and end point for the plane, referencing Jaren, correct me if I'm wrong. That might have been wrong, but I'm 99% sure that the boat distances are correct. But that still doesn't account for the exponentially larger size of the southern hemisphere and how the boat wouldn't be able to go that fast. And I invite people to check my math. Please check my math. Don't just say I'm wrong. Check it for me.
Right, so I'm just waiting to see if there are any more questions, or I don't think there's...
So there's the plain truth as a question.
Okay.
Why can ships be tracked, but planes cannot? Now, this is from a basic understanding of GPS and planes and things like that. The GPS trackers inside of planes are actively tracking the entire flight. I've done this myself. I know many other people have done it as well. You bring a GPS tracker, put it up to the window, it works. It's just not broadcasting back to the ground its location when it's over the ocean, because it's out of communication distance. There are other types of communication that are satellite communication, but if that's not actively being broadcast through the satellite communication, it's not going to broadcast to any type of a website. I'm assuming those boats probably rely almost completely on satellite communication for their tracking, because they spend so much time out to sea. Otherwise, they would have no communication for weeks at a time, where an airplane would be out of communication for hours at a time. I've also got a GPS tracker of my own that I used for a balloon launch several years ago, and it's an emergency beacon, and it can be used anywhere. It broadcasts once every 10 minutes your location, and it does that by sending the signal back up to the satellite, because communicating with a satellite with a handheld isn't that easy, and it's power intensive. So the handheld GPS I had that was an emergency beacon had a button on it to call for SOS, but it doesn't constantly broadcast. It only does it once every 10 minutes. So I'm assuming the boats do that routinely because they spend weeks out to sea where they would have no communication. But I'd have to research that to see if that's valid or not.
Okay. I think we're going slightly off topic when we start asking you to explain why you believe mass attracts mass. It's quite
because I'm building a Cavendish experiment in my bedroom.
Okay, fair enough. Do you want to talk about that for just a minute?
Yeah, I seriously invite everybody to come over to my channel. I am building a Cavendish experiment in my bedroom. I've been building it for about 7 months now. I'm in South Korea. I'm here for another 3 or 4 months before I get to go home. And I have a spare bedroom, and I've always wanted to build a Cavendish. And I started thinking I would build it very simple, just wanting to see if the principle worked. And I started my YouTube channel in November of last year, and as part of that, it's like, hey, maybe ask for advice on how to make it better. So for the past 7 months, I've been building it and ordering parts and trying to remove variables, making sure that nothing else can affect it. I have broadcast multiple test runs online to see if if there's anything else affecting it, temperature, air currents, things of that nature. So I am probably about 98% complete, and I'm getting ready to actually go into full test runs, and I'm going to be using different types of weights. I'm going to be using a lack of a weight to make sure that it's not something else that's causing it, and then I'm even going to try and see if I can run a little a contest. I'm going to put a box on my pedestal where the weights are, not let anybody know what's inside, and see if people can guess what's in there when I put them in place.
Okay. So if we get a response to this video, would you be willing to enter into a debate with someone?
Absolutely.
Okay, cool. I mean, it doesn't have to be specifically on this video, but it could be something,
something
along
the
the same,
topic.
Yeah, on the general topic, yeah. Okie dokie. Right, so listen, before we go any further, I'm going to give you 5 minutes, but then I actually want to do a little bit of promotion here, so I'm just going to bring up this image here, and I'm going to transition across to there. So, Iron Realm Media, tune in, guys. These guys are doing a live stream. Theirs starts in just over 20 minutes time. We've got Chocolate saying he's going to be on there. You guys know him. Iron Realm Media, typically very underwatched. So if you get the opportunity, guys, please head on over there. I'll put the link into the chat. I think I might just do that right now. Let's see. Yeah, so I'll just put a couple of links there. So if you guys want to head on over there when this is finished, I would very much appreciate that. Thank you very much. Right, back to BM. Right, I don't see many more questions coming in. Oh, actually, no. Right, so I'm going to give you 5 minutes if you want to talk about anything, if there's anything you want to promote, anything you're going to be doing, anything, you know, your channel name, everything like that, and tell me when you round it up, and we'll round up.
Okay. Thank you for having me on, Ranty. This is, like I said, very noble of you to open up your platform to other ideas and have a cordial conversation. This is my goal. I know there's a lot of people on my side of the community that do a lot of mudslinging. I've done it a little bit here and there myself, but mostly I try to focus on the science of things, or the basic understanding of things. That's generally my goal. I just did an interview last week and a half ago, 2 weeks ago maybe now, of Mark Sargent. So I spent 2.5 hours on the phone with Mark, just talking to him. No mudslinging, no name calling, nothing else, just because I wanted to understand him. I wanted to understand where he was coming from. So that's where I'm coming from. Question why I'm in South Korea: because I'm active duty U.S. Army soldier. I hit 20 years active duty service next month. So that's why I'm in South Korea. That's the basis of my channel. I try and keep it mostly cordial, other than when silly things require being silly. Come over and check out my interview with Jared, or with Mark. It was very nice talking to him, and that's what I'm kind of trying to get into here in the future. So if anybody on the flat earth side, Ranty as well, if you'd be willing to do an interview, I just want to understand your history, how you came to believe the things you believe today, without telling you you're wrong during that particular conversation. I just want to understand it. So that's the basis of what I'm doing. I just hit 1,000 subs a couple weeks ago. I'm almost at 1,200 now. So I'm happy with my channel, but there's a strong possibility when I leave Korea that it's probably going to die off pretty quickly when I get back to my family. So this is kind of my hobby while I'm here, exploring the globe and the flat earth models.
Thank you very much. So the name of the channel is BM Furball. I'm sure you guys will find it. He's the top of the list there, obviously, for obvious reasons. Check it. How many videos do you have up now?
I think about 80 or so.
Okay, so you've been at this a while then.
Yep. And the majority of them are topical, like this. This was 3 separate videos, but the majority of my videos are specifically topical about one thing that I think supports the globe model. Like one of the videos is on meteor showers, things of that nature. My very first video was earthquakes, and how I think that supports the globe model.
Okay, well, thanks very much for stopping by.
Yeah.
And yeah, if you just want to pop yourself on mute for a minute, I'll just say my roundups, and I'll chat to you once the stream's finished. Cheers. Right, so yeah, a few shout outs and telling you about how things went today. So we had Nathan Oakley, 1980, who was on before. He did his presentation on logical fallacies. He was assisted by Quantum Eraser. and that video should be up on my channel now. It should have rendered by YouTube. So thanks for having him in. We have in the chat Jose John J. Gonzalez, who has been sending over his watchers when he's rounded up his stream to come and send them over here to actually make sure that this actually gets off to a flying start. So thank you very much for that. Phil Bell, thank you for the super chat. I do appreciate it. I know JQ gave a super chat before, and somebody else. I don't know how to get into the super chats to find out who that was right now, but I do appreciate it either way, and I did shout you out, I think, at the time. So that's much appreciated. To all the flat earthers and the globe earthers that came in, thank you very much. I'm sure that this will be a little bit of a hot topic over the next few days, and we'll see what happens, whether this presentation stands up to scrutiny or it doesn't. In any event, thank you guys for all stopping by, and I'll see you on the next one, hopefully on Monday, maybe with the Adam Meakin, maybe, if I can twist his arm to get a presentation done by then. And yeah, I'll see you again in the next one.